Assalamualaikum warahmatullahi taala wabarakatuh. A very good morning to the panel and the audience. I would like to present my project, which is fuzzy logic for herbs and vegetables, small scale agriculture.
My name is Muhammad Zaili bin Zana Arifin. My supervisor is TS Muhammad Azmi bin Said.
As introduction for my project, today's world overtaken by the automation of Internet of Things and plants that play a vital role in maintaining the ecological cycle. The most difficult aspect in agriculture field is to improve the tools and technologies that enable the farmer to increase their productivity, such as a modern agriculture method, crop quality management, and the use of Internet of Things technology, IoT, and Arduino. The main aim for this project is to propose prototype of fuzzy logic for herbs and vegetable small-scale agriculture. As objective for this project is to simulate the fuzzy logic system as to get the prediction of fuzzy logic for herbs and vegetable small-scale agriculture for this project result. Second, develop experimental hardware consists of ThinkSpeed cloud storage to store the data, monitor and control of fuzzy logic for herbs and vegetable small-scale agriculture, and validate the simulation result. And for the third, analyzing and purpose good method for growing mini-scale agriculture utilizing recent fuzzy logic control method. For problem statement, most of the users use a manual system to irrigate crop, but this system is not efficient. It might harmful if overwatering. Second, labor dumping result is high labor cost for monitoring overall crop yield. And third, people do not know to planting, and it will be ineffective crop care and lack of observation to crop growth defect. In the methodology, we use two types of input, is for software input and hardware input. First input, for software we use light intensity, soil moisture, pH level, and water level. For the software processor, we use MATLAB to simulate the fuzzy logic, and then we get the output of result based on the fuzzy logic system. And then for the hardware, we use LDR sensor, soil moisture sensor, pH level sensor, and ultrasonic sensor. As the processor for the hardware, we use ESP32. And then for hardware output, we have two types of line, which is we have pak choy and we have cilantro. By this project, we have three steps as the general to create the goal for this project. First, we need to simulate the fuzzy logic as to get the parameter for the simulation, and then we developing the coding into Arduino IDE, and after that the final we build the prototype, and then we make a analyzed result based on the simulation and the real result. Here the flowchart for this project. First, we start with the timeline flowchart. For the firstly, we do a research and collecting all the data, and then we understanding the simulation and the theory for the fuzzy logic. After that, understanding the Arduino program with IoT, and then we design the simulation of the fuzzy logic using a MATLAB software. After that, we design the Arduino program flowchart. After that, we develop the programming language based on the Arduino with IoT system and fuzzy logic system, and then we test and run the program. If successfully, we need to modify and implement to the hardware, and then we do an observation for all the output and collecting all the data. After that, we design the proper hardware and develop the hardware, and after that we finish for the report. And then for the flowchart, as to develop the system, first we develop of the project structure and the system, and after that we determine the project method. First, we do in the MATLAB software, we design the project, and then we generate the output. This is all for the simulation. And then we do for the hardware, which is first we selecting the Arduino software, and then we design the integrate coding with the IoT system. And after that, after we finish develop the software and also the coding for the hardware, we do a combination for the fuzzy logic system into Arduino system. Then we develop the prototype for the hardware and run the hardware, and after that we complete the project. For the result, there's two types of result. First, we have result that can display on the ThinkSpeed, and the result can be storage. For the first result, for the first sensor, which is pH sensor, will display the pH value in the water storage, and then the LDR sensor will display the intensity of the light, and third sensor, which is moisture sensor, will display the moisture of the soil, and for the ultrasonic sensor will display the level water in the water tank. Next is the output data for the fuzzy logic. First, we have rules view, and second, we have surface view. For the rules view, we can see the combination of 4 input and the result for the plant. First, we can see the result for the soil moisture, and then light intensity. After that is pH value, and lastly is water level. In the rules view, we can set up the parameter on what we want to see for the plant result. As example here, we can see the soil moisture is put in 310, light intensity we can see at 604, pH value we can see in 6.4, and water level in the 16. So the plant result will be 15. And after that, for the surface view, we can see the result of soil moisture versus light intensity, and also we can change to water level versus soil moisture. For the conclusion for this project, all the objective for this fuzzy logic for herbs and vegetable small scale agriculture has already been made before the end. This project can be implemented in a real product and monitor using an IoT system. Right from that, the procedure will undoubtedly to be ready, harvest and eat safely in the end. Thank you.
And now I would like to demonstrate for the fuzzy logic system. First, we need to open the MATLAB software, and then we open and then we type the fuzzy. So here the fuzzy logic interface, and then because I already done the simulation, so I just import the file from the file. So it will go here. This my fuzzy logic system for the simulation, and here I already create the 4 input for the system represent for sensor that I use. First sensor which represent for soil moisture. Uh, for the neck is light intensity represent to LDR sensor. pH level represent to pH sensor, and water level ultrasonic sensor. So we just click the input, and then we set up the parameter for the all input. As example for the soil moisture, there is 3 condition: dry, good and wet. And then for the light intensity, we have three condition, which is dark, low light, and the last one is bright. And next, for the pH level, also we have 3 condition, which is alkali, acid and neutral. And then for the water level, we have low, middle and full. And then there is a plant result that we can to see the result. So I make in 3 condition, which is bad, good and excellent. So after done with the input and plant result input, so we can go to the fuzzy logic rules in here. So I choose a Mamdani. So in here, we need to create the condition represent to parameter for the input. In here, we need to create as much as possible. So for this system, so I create up to 81, which is the maximum that I can create. So for the first rules, I already made, which is soil moisture is dry, light intensity is dark, pH level alkaline, and water level is low. So the plant result will be a bad. So after finish until 81 rows, and then we can go to the result. As to see the result, there is two type of result that we can analyze based on the result that we have get. So the first result we can see on rows. Uh, so in rows, we can adjust the result for all the input. Let's say summation we put 334, light intensity we put 884, and then pH level around 6.4, and then water level in the water storage we put in 14.8 liter. So the result will uh, come out for the 15, which is in a good condition. And then the another result for the surface. Surface is more like to see the versus example. For we can see here light intensity versus to pH level, or we can change to soil moisture versus to, let's say, water level. The difference here, we can see where the condition of the between these two sensor start to show the good performance for the system. So we can see here, for example, for the water level. So the highest one is here. So the plant result will go in a good condition, start from 10, and then if we look back the plant result here, 10, start from 10 to 20 will be the good result. So we can see start from 10, and then we go the another axis, which is for the water level. So it show that start from 100 up to 400, it will the plant result will go to good result. So this analysis comparison between the two sensor. And now we like to demonstrate for the hardware part. For this system, there is four sensor that can we show the data, and then we can record the data. So in this interface, we can see the pH sensor, LDR sensor, and moisture sensor, and ultrasonic sensor. So for the hardware part is here, which is in here already did the soil moisture sensor, and behind of this board it have a ultrasonic sensor and also a pH sensor, and then beside here it have a LDR sensor. So for the demonstration for the moisture sensor, so I take off this, and now water pump is already turned on. So we need to put back, and then water pump is turned off, so you can see the water is filled up. So we go to LDR sensor, and I will close the LDR sensor to show dark condition, and then we can see the light is already turned on for this system. And then in this result, it will show the data that the light is in dark condition. So the pH sensor, uh, it will show the value for the level of the sensor, level of the pH sensor. For the pH sensor, is located in the water container, so it's hard for me to demonstrate. So I just show the result. So for the ultrasonic sensor, when I put up
this lead in the letter, it show that the value for the water level in water tank go down to negative because the water level is very low condition. So when I put my hand to the water level, so it show the tank liter.